Welcome to the continuity session of Introduction to Reinforced Concrete Element. In today's session, we are going to see about the design philosophies and how a load is transferred in the structure. In last class, we have seen what you mean by reinforced concrete structures and what is concrete and what is steel and what are all its properties and how it will behave as a composite material as reinforced concrete. In today's session, we are going to see about the load acting on the structures. That is, commonly the load acting on the structures are dead load, that is self weight of the structure, live load, that is the occupancy, the movement, the people who is occupying that place or the materials which is occupying that particular area can be considered as the live load, and wind load, earthquake load, temperature and shrinkage effects, and also we can include the accidental loads. So these are all the different types of loads which act on a structure and the structural elements and their functions, because we know that the load is acting on the structure, but how the load is transferred from that structure to the ground. So in this we can see here, because generally the load which is acting on the slab, generally the slab is the first portion where the load will act, and from slab the load will get transferred to the beam, and from beam the load will get transferred to the column, and from column it is transferred to the foundation, and from foundation it is transferred to the soil. So if you see in this figure, you can see the load is first acting on the slab, from slab it is transferred to the beam, and from beam it is transferred to the column, and from column it is transferred to the footing, and from footing it is transferred to the lower soil area. So here in slab the load will be act like an area load, that is per meter square load, and from slab it is transferred to the beam which will act as a per meter load or UDL. And coming to the column it will act like a point load, and from column to foundation also it will act like a point load, and from foundation to soil it will act like an area load, because the starting point is also area load and ending point is also an area load. So this is the structural element and their function, how a load is transferred from the top of the building to the bottom of the building, that is foundation of the building. So demand on structural elements, what we expect from a RC element, because nothing but we need strength, stability, stiffness, durability and serviceability. These are all the general expectation of a public who is constructing a building, because the structure should be a strong one and it need to withstand for a longer lifespan, that is for 100 years or 150 years they expect the structure to withstand, and durability and serviceability, all the things will come under that lifespan expectation. So design philosophies, generally the concrete structure, that is reinforced concrete structure, is designed based on three philosophies. First one is working stress method, limit state method and ultimate load method. So the working stress method is the first method. So I am going to give an overview of this design philosophies, and I will attach another video which will be a very detailed one for this design philosophies alone. So here if you see, in working stress method the structure is designed based on the elastic behavior and will use only the permissible stresses, that is load which is acting on the structure is directly considered for the design. And here we will use a factor of safety for materials alone. This is suitable only for service load conditions, and it will give high importance to the serviceability of the structure is the higher importance in this working stress method. And the advantages and limitations of the working stress method, it is simple and easy to understand, and it will provide good control on deflection. Disadvantage, it does not predict the ultimate strength, because we are only applying the factor of safety to the material alone, not to the load, and it will lead to conservative designs. And here always the section size will be larger, because we are applying the larger factor of safety to the material strength, which will reduce the load carrying capacity of the material, which will lead to the larger sections. And next one is ultimate load method. This ultimate load method which was introduced to overcome the deficiencies in the working stress method, and also in this method the main drawback is it omitted the serviceability concept of the working stress method. Here it is based on the collapse load, that is ultimate load, and here we will use the ultimate load concept and it will provide economical section. But the main drawback, as I have mentioned, we will omit the working stress method concept of serviceability. Here the serviceability is not adequately addressed. That is the main drawback of this ultimate load method. Next one is limit state method. This limit state method is the combination of both working stress method and the ultimate load method. Here it will consider both the serviceability and safety of the structure. If you see, the working stress method considers serviceability and ultimate load method considers safety, but this limit state method considers both the safety and serviceability, and here we will use partial safety factor. Why we are calling it as partial safety factor means the factor of safety is applied to the materials and also to the load. So it is applied for both the scenarios, that is for load and for material. So it is called as partial safety factor, and it will check the ultimate load carrying capacity and serviceability of the structure, and this method was recommended in our IS 456. So limit state, here we have two types of limit state. One is limit state of collapse and another one is limit state of serviceability. So limit state of collapse will consider the shear failure, flexure failure and the stability of the structure, and limit state of serviceability considers the deflection, cracking and vibration. So while designing a structure or as a element, we need to satisfy both the limit state of serviceability and limit state of collapse. So the comparison between working stress method, limit state method and ultimate load method. So limit state method is elastic, it will consider only the up to elastic limit and it is conservative, and ultimate load method it considers or it will focus on the ultimate strength of the material, and limit state method it balance both the safety and serviceability and also it is economical. So in nowadays the limit state method is widely adopted for design. So here if you see, various criteria has been given and it has been compared with the working stress, ultimate load and limit state method. Though stress strain behavior we consider only the linear elastic here, but here we consider the plastic. Here if you consider in limit state method, we will consider both the elasticity and plasticity condition in this limit state method. Safety parameters, the factor of safety. The factor of safety is used only for materials. Here load factors are used for loads alone. Here we will use the partial safety factor for both the load and the material. Economical section, here uneconomical section, because as I mentioned we are giving only consideration to the serviceability, so the size of the member is very high. Here if you see the economical section, because here we are considering only the load factor and not considering the factor of safety for materials, so we will have a thinner section. And here if you take the limit state method, we will have optimized section, which will, because it consider both the working stress method consideration and the ultimate load consideration also. Serviceability, it will have good serviceable life. Here the serviceability not considered, because not guaranteed, not considered, it's not guaranteed, because we are giving only importance to the load. And here we have both the conditions, that is we are also check for the collapse and also we will check for the serviceability, so it will have a very good property. So with this we will close this session and we will continue in the next session. Thank you.